Assalamualaikum students, today is our new lecture and its name is power series. Any function can be represented in the form of power series. So general representation of the power series is y equals to c naught plus c1 into x plus c2 into x square to so on cn x to the power n. Basically, it is a polynomial function, so it can be represented in the combination or combined form or in the compact form. And for the compact form, I am using this sign, that is sigma n equals to 0 to infinity cn x to the power n. So this is the generalized power series and it is centered at, if x is centered at, then we represent this function as in the form of power series. So we solve this with the help of example. And function is given by y dash equals to, that is differential equation. So in this topic we will study the differential equation, how to solve the differential equation with the help of power series and to find its differential with the help of power series. So this is the differential equation, that is y dash equals to minus 2 into y. And one more thing is, we compare it, we get the solution, we extract the solution out of the power series with the help of power series, and also we original or analytical solution with the power series. So that should be equal, or that should be identical. So by first step is I have to find out its analytical solution. So for solution, analytical solution, dy by y dash is dy by dx and minus 2y. So how it can be solved? By any method. You can also apply separation of variables, you can also apply linear integrating factor with g of x or f of x equals to 0, and any other technique. So here I am using the separation of variables, and that says that 1 by y dy equals to minus 2 into dx, and I integrate this on both sides. That becomes natural log of y equals to minus 2x, and y equals to, by using log property, e to the power minus 2x plus, sorry, one more thing is plus c. So e to the power plus c. So if I say that property is minus 2x into e to the power c, if I say it, because e is also a constant and c is also a constant, so you can use this as c1 e to the power minus 2x. So that is the analytical solution or exact solution of this given differential equation, y dash equals to minus 2 into y. Now, in the next step, we start this solution with the help of, we solve this differential equation with the help of power series. Equals to c1 e to the power minus 2x. This is the analytical solution of this given differential equation. First step is, we assume the power series just like this. So our assumption is, let y can be written in the form of this power series cn x to the power n. It can be differentiated term by term. So if we apply the first derivative to this, then it becomes y dash equals to n equals to 0 to n, and cn is a constant, so differential operator does not affect on the constant. So cn, but it affects on the x term, that is variable term, and by power rule it says n into x to the power n minus 1. Index can never be a negative term, as that is why we start this first derivative from the n equals to 1. So y dash equals to summation n equals to 1 to infinity Cn n x to the power n minus 1. So the index can never start from the negative term. Now put this y dash and y in this given differential equation. Then it will become y dash is n equals to 1 to infinity Cn n into x to the power n minus 1 equals to 2 into y, minus 2 into y. So y is our by assumption n equals to 0 to infinity Cn x to the power n. And I multiply this, will shift this minus 2 towards the left hand side. So what does it become? It becomes n equals to 1 to infinity Cn n into x to the power n minus 1 plus 2, n starts from 0 to infinity Cn x to the power n equals to 0. So we have to combine this summation form, and for that we need to make this index equal. So one index starts from 1 and the other index starts from 0. So what we need to do, we have to re-index one of these two indices to get the common index. I want to re-index first this term so that its index remains same. Re-index this initial, because it starts from 1 and the other starts from 0. So re-index to make the initial term starting from n equals to 0. So how can you re-index it to make it start from the 0? If I suppose that let k equals to n minus 1, and when n equals to 1, then k will be starts from 0. Now it is re-indexed. So this term becomes k equals to 0 to infinity ck into k is, instead of n minus 1, it becomes n equals to k plus 1. So here you can replace k plus 1 and x to the power k, and second term is as it is, Cn x to the power n equals to 0. Now in the next video we will do it